Here we are at example 5 from our 1.3 number 2 set of notes. We're asked to evaluate this piecewise function. Now we have the limit as x approaches 0 of the function, and the function is actually defined by this piecewise guy. Now anytime that we see this piecewise function, we've talked a little bit about this from class, but you should be thinking one-sided limits. And so we're trying to prove that the left side does in fact meet up with the right. So as a result, we then end up with a left side and a right. And hopefully they just end up meeting up at the same spot. Looking at the left side, again, 0 happens to be that magical number that this x is approaching. So it's broken up, our piecewise function is broken up by that value, that x value is 0. So on the left side, in other words, numbers that are less than 0, that'd be like -1, -2, -3. All these numbers less than 0, you would use this top piece for. And numbers larger than 0 or equal to 0, you would use this bottom one, or your right side. So again, this part would be considered to be like your left, or you'd have 0 to the left, and these ones you'd have it's approaching 0 from the right side. All right. So on the left, we are going to go ahead and use this function, this top part. So we end up with then x squared. We're going to take the limit, I should say, as x approaches 0 from the left of x squared plus 2 times the cosine of x plus 1. Well, if we just go ahead and try direct evaluation, we end up with 0 squared plus 2 times the cosine of 0 plus 1. Well, 0 squared, that's not bad. That's just 0. The cosine of 0, as we know from trig, is just 1 times 2, just comes out to be 2, plus 1. So we really have 0 plus 2 plus 1, which is just 3. Now let's check out the right side. What's going on there? Well, same setup. We have the limit as x approaches 0, but again, this is from the right side, because we're dealing with x's that are larger than or equal to 0, of our function. So we have e to the x minus 4. Again, with this piecewise function, for the values larger than 0, we're going to go ahead and use this part of that piecewise function. Now, going ahead and throwing in 0 into the function for x, we end up with e raised to the 0 minus 4. And e to the 0, if you think back to algebra 2, e to the 0 is a function that just looks something like this. Or I'm sorry, e to the x is just a function that looks like this. But e to the 0 has a y value of 1. So e to the 0 is actually just 1 minus 4. So it appears that this limit, in fact, comes out to be -3. Now, unfortunately, as you guys can tell, the left side does not match the right side. So because the one-sided limits are different, the limit as x approaches 0 of our function f of x does not exist. So again, that is example 5 from our 1.3 number 2 set of notes.